All right, so do we want to condense this? Is that what we're trying to do? Make it a single
Yes.
log? Okay. I'm going to write as a single log. So the ones that are positive, these first two, they will be in your numerator. The ones that are negative, these back two logs will be in the denominator when you go to combine them. So I would combine the first two and then combine the second two. So we're looking at log of x times x squared minus 4 minus log 8 times x minus, x plus 2. So you can bring them together like that. And then this ultimate minus sign, ultimately this minus sign will make us set up division. And really we can simplify this. I'm assuming they want you to go ahead and simplify it further, since x squared minus 4 is x plus 2, x minus 2. And x plus 2 is cancel. And then it'll be log of x times x minus 2 over 8.
Okay, thank you.
Yep, not a problem. All right, anybody still copying before I go off this page? All right. So let's look at 4.4. So we're going to use all of our skills up to this point to solve these exponential and logarithmic equations. So we're going to go through different methods of doing so. Some equations you can use multiple ways of solving. And so you just use the method that you see as to be the best method at that time. But some equations you will have multiple options in order to be able to solve. So the first one we're looking at is using the same base to solve. So if we have b to the m power equal b to the n power, then I can drop the bases and be left with just the exponents to solve. That's what I said right here, drop the bases. So if I can manipulate the problem and have the same bases on both sides of my equal sign, I can drop the bases and I'll be left with the exponents. And I can just solve whatever is left from my exponents. All right. So looking at this first problem, 2 to the 3x minus 8. 3x minus 8 is an exponent. And that's equal to 16. So we can look at it as 16 and ask ourselves, is it possible to write it in the form of 2? In other words, base 2. You know, is 16 a multiple of 2? And the answer is yes, because that's 2 to the 4th power. So I can rewrite this equation as 2 to the 3x minus 8 equal to 2 to the 4th power. Now, since my bases are the same, I can drop the bases and be left with just the exponents. 3x minus 8 equal to 4. And now I can just solve this linear equation. Add 8 to both sides. And divide by 3, and my solution is going to be 4. All right, questions before we go to the next one? All right. So the next one, we have 27 x to the, 27 to the x plus 3 power equal to 9 to the x minus 1 power. So if we're trying to use the same method of having the like bases, then we need to be able to either change the 9 to a 27, change the 27 to a 9, or find something that they have in common that we can change both of them into. So in this case, both of them are multiples of 3. All right, so 27 is 3 to the third power. 9 is 3 to the second power. So we can change these to a multiple of 3. And here in the red, power to a power means that you're going to multiply your exponents. And so here, that's going to be 3 times x plus 3. This is going to be 2 times x minus 1. So that's what I did here, rewrote it in that fashion. Remember, whenever you're raising a power to a power, that means you multiply your exponents. All right, go ahead and drop the bases and solve. And you just solve your linear equation as you normally would. Distribute 3, distribute 2. 3x plus 9 equal to 2x minus 2. Get all of your terms with x on one side, all of your terms without x to the other. So you'll subtract 2x from both sides. X plus 9 equal to negative 2. Add minus 9 from both sides, and x will be equal to negative 11. All right, questions? Any questions? The next method is to use logs in order to solve. So we take the natural log of b to the x power. You can bring that x down front. That'll be x times natural log of b. Take the natural log of e to the x. Don't forget the principle of how natural log of e will cancel and leave you with just the exponent. Same thing with the common log of 10 to the x will cancel and leave you with just the exponent. So he's just re-emphasizing principles from 4.3. But we can use these thoughts in order to solve. So in this first one, we have 4 to the x power equal to 15. So now don't forget, this is not 4x equal to 15. So I can't divide both sides by 4 to get x by itself. I have x as an exponent. So in order to get x down front, so I can treat it in which I can divide and everything like that, I need to get it out of my exponent. So that's why we're going to use this first rule right here that will enable us to bring x down. So what we'll do is apply the log to both sides. All right. Apply the natural log to both sides. You use common log. In this case, it doesn't matter because neither one of them will cancel. You have a 4 and a 15. The 4 cannot cancel with the natural log or the common log. Neither can the 15. All right. So now what that enables us to do, though, is that now we can take that variable of x and bring it down front. All right. And that gives us x natural log of 4 equal to 15, equal to natural log of 15. And so now what we would do is divide both sides by the natural log of 4. All right. So now be careful here. These natural logs cannot cancel. You can't go natural log over natural log and cancel them out and have 15 over 4. Natural log or log period is a application. So what you have is this whole thing. Natural log of 15 is a number. Natural log of 4 is a number. So you can't just cancel out natural logs and have 15 over 4. All right. So either you're going to put in the exact answer, natural log of 15 over natural log of 4, or go ahead and approximate that by throwing in your calculator, and that'll be 1.95. And always make sure if they want an approximation that you pay attention to directions. If they want to two decimal places, 3 decimal places, or so on, make sure you pay attention to that. Because if they want 3 decimal places and you put in 1.95, pretty sure my math lab will mark it wrong. So make sure you pay attention to that. All right. Questions on that? All right. So here we have 10 to the x equal to 120,000. So now, before we use natural log, and like I said, it didn't matter whether you use natural log or common log, it will be in our best interest in this case to use common log because we have this 10 here. Remember, common log has the base 10. And so that's what I said right here in the red. Since we have a base of 10, we use the common log. So you apply the log to both sides. The x is going to cancel. I mean, not the x is going to cancel. The log and the 10 is going to cancel, leaving you with just x. And then log of 120,000 will be 5.08. All right, questions? Any questions? All right. Next one, we have 40 e to the 0.6x. So this 0.6x is an exponent. Minus 3. And that's separate from that. It's kind of right, so it look like it's separate. So that's 40 e to the 0.6x minus 3 equal to 237. All right. So the first thing we want to do is isolate this exponential function. So isolate the term with x as an exponent. In this case, we have e with x as the exponent, but we want to isolate that. So we'll add 3 to both sides. And that'll give us 40 times e to the 0.6x equal to 240. Then we'll divide both sides by 40, leaving us with e to the 0.6x equal to 6. Questions so far? All right. So now we want to, once again, our goal is to get, didn't mean to have my eraser still on, get this 0.06x out of the exponent because we need access to the x. So we're going to apply the natural log to both sides. And notice here in the red, since we have base e, then we will use the natural log. Remember, the natural log has the base of e. One of those times wherein using the natural log will matter in reference to using the common log. And so that cancels out this part, leaving you with just 0.06x. So you're left with that. Then you divide both sides by that 0.6. And you have natural log of 6 over 0.6, or 2.99. All right, any questions? All right. So the next one, we have 5 to the x minus 2 equal to 4 to the 2x plus 3. The x minus 2 and the 2x plus 3 are exponents. Once again, we need access to those x's in the exponents. So what we'll do is take the natural log and apply it to both sides so that we can bring those exponents down front. All right, so we have x minus 2. Well, first of all, we have natural log of 5 to the x minus 2 equal to natural log 4 to the 2x plus 3. We take the natural log, apply to both sides. Now we'll bring down the x minus 2 because it was an exponent, and the 2x plus 3, which was an exponent. So we have x minus 2 times the natural log of 5, 2x plus 3 times the natural log of 4. So be careful, notice the parentheses here. That natural log of 5 needs to be applied to each term from that exponent. Same thing with the natural log of 4. All right, and remember that's one quantity, so we're going to distribute that. All right, let me erase this stuff first. All right, so this is what we have. We have x times natural log of 5 minus 20, not 20, minus 2 times natural log of 5 equal to 2x natural log of 4 plus 3 natural log of 4. All right. Questions on what we did there. So now your goal, notice we have x in 2 different places. Your goal is to get x, all of your terms with x on one side, all of your terms without x to the other side. So I'm going to subtract 2x minus 4, 2x natural log of 4 from both sides, and add 2 natural log of 5 to both sides. So the x term will cancel out on the right. And then the term that does not have x on the left side will cancel out. And that will leave us with, I still have my eraser on. I keep forgetting to do that. That leaves with this equation. X natural log of 5 minus 2x natural log of 4 equal to 2 natural log of 5 plus 3 natural log of 4. All right, make sure everybody's with us. All right, so now we can factor out x. We have x in both of these terms, so we can factor x out. This would be the result. X times natural log of 5 minus 2 natural log of 4. Then we will divide both sides by that quantity of natural log of 5 minus 2 natural log of 4 to both sides. And that will be the result, negative 6.34. Any questions before we go to the next one? All right, so the next one we have e to the 2x minus 4 e to the x plus 3 equal to 0. So here we have a quadratic. I don't think I spelled quadratic right there. Put an extra C in there. Do it like this. We have a quadratic scenario. There you go. So if you look at the form, we have e to the x squared in this first expression. Then we have minus 4 times e to the x. So we talked about this type of scenario before. I believe it was back in chapter 1. Whenever you have this squared right here, you have a quadratic scenario. Okay. So if we want to simplify this so that we can solve in an easier way, we can just let u be equal to e to the x. So that will give us this u squared minus 4u plus 3 equal to 0. We factor that out. And so notice I said solve quadratically. So whatever your method is to solving your quadratic equations, you can use. I decided to go ahead and factor because it was factorable. If you want to use the quadratic formula, you could have done that as well. Still get the same values. So I got u minus 3, u minus 1. Solving those out will give me the solutions of u equal to 3 and u equal to 1. All right. So now, don't forget, we didn't start off with u. We started off with e to the x. So we put e to the x back in for you. So it's going to be e to the x equal to 3, e to the x equal to 1. Now, once again, I need access to this x here. And in order for me to do that is to apply the natural log to both sides. Doing that here cancels out e, leaving you with x equal to the natural log of 3. That would be approximately 1.1. Same thing here. but then the natural log of 1 is always 0. So those would be your two values. All right, questions? Any questions? All right. Next way or next method is to use the log form to the exponential form, vice versa. All right. So we talked about going back and forth between these two relationships, log base x equal to y. Log base b of x is equal to y. That means b to the y is equal to x. So if I have log base 4 of x plus 3 equal to 2, I can use this relationship to rewrite that log expression or the log equation. So remember, your base is 4. Remember, you always start off with your base. Remember, I said whatever's next to your base in one form should not be next to the base in the other form. So this will give us 4x squared, 4 squared equal to x plus 3. Rewriting it in exponential form. All right. So then you go ahead and solve. 4 squared is 16. Minus 3 from both sides. X will give you 13. Any problems? Any problems? All right. Looking at the next one. 3 times the natural log of 2x equal to 12. All right, so first thing we do is divide both sides by 3 so that we can get the natural log of 2x on one side by itself. All right, so don't forget the natural log is the same thing of log base e. So remember this method, we're talking about changing your log to exponential form. So that's what we did here. E is my base. So it's going to be e to the 4th power equal to 2x. Then divide both sides by 2. And your answer is e to the 4th over 2. All right, questions? Any questions? All right. Next type, we have log base 2 of x plus log base 2 of x minus 7 equal to 3. So if we have this scenario, we want to condense the logs. In other words, bring your logs together to write as a single log. Now remember, you only can do this if the bases are the same. If the bases are not the same, then you have to do something else. But since the bases are the same, you can bring it together as multiplication. Addition means multiplication. So that's x times x minus 7 that's being applied to the log. And now I can rewrite that in exponential form. Log base 2 to the third power equal to x times x minus 7. All right. Now we just solve the quadratic equation the way we normally would, distributing x. That'll give you x squared minus 7x on the right side. Then you want to set one side equal to 0 and by subtracting 8 from both sides. That'll give you x squared minus 7x minus 8 equal to 0. All right, so now solve your quadratic equation. So they give us x minus 8, x plus 1, giving us two solutions of x equal to 8, x equal to negative 1. And we do need to go and check them, so we'll do that in a second, but you do need to check your answers because remember there's certain stipulations on logs. You know, like you can't take the log of a negative. And it's not about your solution being negative, but you need to check to make sure that your log isn't being applied to a negative. So do that in a second, give you guys a chance to copy. All right, so plugging in 8. And I did this by hand. Of course, you can plug it into your calculator, do log base 2 of 8, log base 2 of 1. You can get 3. Then if you plug in negative, now once again, it's not about your solution being negative. It's about when you plug it in, will you be taking the log of a negative? In other words, if I had the log of, uh, let's say, negative 1 plus 8, that would be log of 7, which is fine. But if, you know, if I was plugging in x right here, so that would be fine. So it's not about your solution being negative. It's about when you plug in your solution, will you be taking the log of a negative? And you see that when we plug in negative 1 in this case, can I take the log of that negative? See, it happens here and here. And so x is the only solution. I mean, x, 8 is the only solution, and that negative 1 is not a solution. All right, questions? Any questions? So, next one, the one-to-one property for logs. Very similar to having the basis. That was really the one-to-one property for your basis. But same thing here. If I have the log base of m, a single log equal to another single log, and they have the same basis, then I can drop the logs and just be left with x. All right, so if I can condense my logs to a single log on both sides, then I can just drop the logs. So that's what we're looking at in this first one. We have natural log of x plus 2 minus natural log of 4x plus 3 equal to natural log of 1 over x. So first thing I want to do is condense those logs. This minus sign means I rewrite it as division. So it's x plus 2 over 4x plus 3. Then I can drop the logs. And that'll give you x plus 2 over 4x plus 3 equal to 1 over x. Now we just solve this equation the way we normally would by cross multiplying. That gives us x times x plus 2 equal to 1 times 4x plus 3. All right, so x squared plus 2x equal to 4x plus 3. And it's quadratic equation, so once again, we want to set one side equal to 0. Subtract 4x and subtract 3 from both sides, and that'll give us x squared minus 2x minus 3 equal to 0. All right, any questions, any questions? All right, go ahead and solve the quadratic equation. Get the solutions of x equal to 3, x equal to negative 1. And just like before, plug them in, and you will find out that x equal to 3 works. X equal to negative 1 will not work for you. Questions, any questions? All right, okay, so that's one of the examples. Questions on anything I've said? Okay, so those 4 sections out of chapter 4 will be on your next test. Let's see, how much time do we have in the class? Um, hmm. I need to make a decision on what I probably would do is let this test be the last test. So our final exam week is the first week in May. So that's 5, 3, 2, 5, 7. So I'll probably let this be our final test. And your test, so that I can give it to you and give you 2 hours to take it, because you know the final exam has to be proctored. So yours will be on 5/3 at the same class time, which is, this class starts at 11. And so, like I said, I'll give you 2 hours to knock that out. So 11 to 1. And it'll be on chapter 4, because that pretty much will sum up everything that we've done up to this point, even from the beginning, using quadratic situations to solve and linear equations to solve as well. So we'll do it like that. So I'll be sending you an email on that and instructions and all the good stuff like that.
Professor, I have a question.
Mm-hmm.
Then we were just gonna have just one proctor test, or is it 2 of them?
Let me see. How did your class work?
'Cause-
Because I know we tried to do it. No, you guys think no, test 3 was proctored.
yeah.
Yeah. So this is, yeah. So as far as test goes, then test 3 was the last one, the only one that was proctored. So now this final exam, this final test will be proctored as well.
Okay.
Yeah. So, yep. So we'll do it like that.
Are we gonna
And
have a second chance to do it?
if we do, it would be contingent upon the fact that you did do it the first time. So I'll work that out. But since it's your final exam, what I don't want people to do is just like not show up at all for your final exam. You know what I mean?
Yeah.
So I'll work out some details on that. But and then if I do, oh, where my stuff go? If I do a makeup for the final, it probably won't be as high as 85. Because it's supposed to be the final exam. Like I'm supposed to be encouraging you guys to actually take the final exam. You know what I mean?
Okay. I
Yes.
do have one more question. Is it gonna include older chapters or just
No, I'm just gonna do chapter 4.
Oh, okay. That's fine.
Yeah, I'll just do chapter 4 because, like I said, chapter 4 still pulls on the stuff from previous chapters and stuff. So if you just do 4.1 through 4.4, like you saw in this section, it's still gonna pull on your knowledge from previous sections. So we should be fine just doing chapter 4.
Okay.
This test is gonna happen in May?
Mm-hmm.
Okay.
So are we gonna keep having class after this?
Yeah, so what we're gonna do this Monday, let's go ahead and look at the schedules because this time will go by, quicker than you think probably. Yep, 26. And this is gonna be 21, 28, and this is 5/3. So we're talking about Mondays, Wednesdays. So this Monday we won't have class because I have a funeral to go to. So here we'll be reviewing because we just closed out chapter 4, and so really we only have 2 of the days that really kind of like free days. I could have brought in new material, but I don't see a reason for doing that. So it'd just be you guys prepping for this final test and making sure you're straight.
So during those 2 days, can we, if we have any other work we didn't do, can we still finish it?
Oh yeah, you're gonna have. I'm not gonna change my math lab dates. Everything's due. I think it's 5/9 that I have in my math lab. It should be if it's. I haven't went back and adjusted. It may be 5/7, But I'm giving you guys till 5/9, which is a Sunday, to submit anything in my math lab.
Oh, okay. Thank you.
Yeah.
I do have one more question.
Mhm.
So since I have a C in this class, I thought I was gonna get extra credit for one of the tests since I did the test review.
Mhm.
So
Well,
I'm not
I do all
sure.
that at the end. Yeah, so it wouldn't show up right now.
Okay.
Yeah, so there's no way in my math lab that I can program it to like automatically add points and stuff like that. So
Oh, okay.
yeah, so
Okay.
instead of me going, individually, because everybody does it at different times and everything, I just calculate all that at the end.
Okay.
Yep, yep. All right.
Mm.
Anything else? Anybody else?
I had one more question, but I forgot. Yeah, I forgot. I'm sorry.
Oh no, it's fine. It's fine. Well, you got 3 days.
Oh yeah. I have one
Okay.
more question.
Mhm.
Do we have to do those other activities or just chapter 4?
Oh, you talking about after 4.1?
Yeah.
I mean, not 4.4. No, you don't have to. No.
Okay.
So you can stop at 4.4 in your homework.
Okay. Thank you.
Anything else? Anybody else? Anybody? So we will be, like I said, reviewing those next 3 days. Basically, I'll come to class and you ask whatever questions you have. And that'll be it. So I wouldn't be bringing any new material. I won't be bringing anything. You guys will just, if you have questions, you come to class and bring your questions. All right. Any concerns, comments? Everybody good?
I love you, Jason.
All right. So if you guys are good, I'm good. I will see you next Wednesday. See you guys on Wednesday.
Okay. Thank you.
All right. Thank you. You have a good one.
You too. Thanks.
Bye. Have a good week.
You do the same. Thanks.